I remember when I was studying for the GMAT, I didn't necessarily think of inequalities as the hardest subject, but I do remember finding them annoying. And the reason for that is because whenever I was confronted with an inequality question, I remember thinking that this problem would just be so much easier if they just gave me an equation. In other words, I think a lot of people think of inequalities this way, where equations are already hard enough, and then people think, now I have to learn an entirely new set of rules when dealing with inequalities. But that is not really the case. And in fact, equations and inequalities have a lot more in common than they don't. And I think people should really approach inequalities as not in a similar way that they do equations, with only a few differences, one or two differences, in fact. And so let's talk about both what equations and inequalities have in common, as well as where they are different. And so let's start with equations. And so say I am given simplest equation. You can think of x is equal to y. And so we're talking about what operations, what manipulations can I do to this equation that are legitimate. And so the easiest thing you can do is you can always add or subtract, as long as you add or subtract the same thing from each side of your equation. And so if x is equal to y, it should also be true x plus 5 is equal to y minus 5. And x plus 5 should be equal to y plus 5. And x minus 5 should be equal to y minus 5. So as long as you do the same thing to each side of your equation, you can always add or subtract from each side. Now say you are given an inequality. X is greater than y. Well, the same thing here should be true. You should be able to add or subtract from each side of your inequality as long as you do the same thing to each side. So if x is greater than y, it should also be true x plus 5 is greater than y plus 5. X minus 5 is greater than y minus 5. So for each case, you can always add or subtract. Again, that's as long as you add or subtract the same thing from each side of your inequality or your equation. Let's look at another example. So now, say I have the equation 5xy is equal to 5xz. And so I want to simplify this. So what can I do in order to simplify this? So to start, can I divide each side by 5? And that shouldn't be a problem. 5 here should just cancel out the 5 here. And so that leaves you with xy is equal to xz. But then can I divide each side by x? If I were to do that, that would give me then just y is equal to z. And I would be saying, so if someone were to tell me that 5xy is equal to 5xz, I can then infer from that y must be equal to z. So is this in fact true? And a lot of people, it seems logical because you're saying, well, the 5 here matches with the 5 here. The 5 on the left side matches with the 5 on the right side. The x on the left side matches with the x on the right side. Therefore, the y on the left side must be equal to the z on the right side. Everything must correspond. But if you were to say that, you would be missing out. You would be overlooking the one example where that is not true. And so we cannot always divide. So we can divide each side by 5, but we cannot always divide each side by x. The reason for that is because there's a universal rule. This isn't specific to equations and inequalities. and that is that you cannot divide by 0. And in this case, when we have this variable x, we didn't put any restrictions on it, and so it can be anything. There are infinite possible values, including 0. And so when that is the case, if x were to be so, in most cases, it would be true that y is equal to z. But when x is equal to 0, it is not necessarily true. So say x is equal to 0. And so on the left side here, we have 5 times 0, and let's say y is 2. So on the right side, we have 5 times 0. And so if we wanted to, so we can make z equal to 2. And in this case, y is equal to z. And this should check out because our left side is equal to 0, our right side is equal to 0. But if x were equal to 0, I could also make my right side equal, or my left side equal to 3, and my right side have my z equal to 4. And so 3 is not equal to 4, and so y is not equal to z. So it means like y is not, could be equal to z, but is not always equal to z. In this case here, when x is equal to 0, it is the only case where this is true. If x were to be any other number, y would always be equal to z. But you still have to take into account, and the GMAT loves testing exceptions. Now let's look at the same example with inequalities. So if I were to say 5xy is greater than 5xz, so it's still true that you cannot divide by 0 when you have an inequality. But here it doesn't really, you don't even get to that point because in this case here, if 5xy is greater than 5xz, what's implicit in that is x cannot be equal to 0. Because then the left side would not be greater than the right side. The two sides would be equal. So again, this is something equations and inequalities have in common. You cannot divide by 0. And the way it comes up a lot is when you're talking about variables, especially variables where they don't give you any sort of restriction. So now let's say, to use the same example from before, 5xy is equal to 5xz. But now they also tell us that x is not equal to 0. So now can I divide each side by x? And you should be able to. So if they tell you with an equation that x is not equal to 0, now you can divide each side by x. There's really nothing else you need to take into account. And you can get y is equal to z. So if x is not equal to 0, it doesn't matter. X can be positive, it can be negative, it can be a positive fraction, it can be a negative fraction. It doesn't matter. You could have, 5 times 2 times y is equal to 5 times 2 times z. Y should be equal to z here because you just divide your side by 10. Nothing wrong with that. If you were to say 5 times negative 2, if x is equal to negative 2, is equal to 5 times negative 2 times z. Well, still should be true, y should be equal to z because your negative 10s should just cancel out on each side. And so what I am trying to get at here is now let's look at inequalities. So we have the same inequality here, and we know from this it's implicit. X cannot be equal to 0. So does that mean we can divide each side by 5x to say y is always greater than z? And be simple way to answer that is, I would say, come up with a simpler example. just choose any two numbers. And so I'm going to say 8 and 4 and make an inequality out of it. So in this case, 8 is greater than 4. So the thing that you need to worry about with inequalities that you don't have to with equations is your inequality sign, because your inequality sign has two possible directions it can be facing. So you have to, whenever you are manipulating inequality, you have to make sure you can predict which way the sign is going to end up. Whereas with equations, well, there's only one sign you got to worry about. The equal sign doesn't have any sort of direction to it. So say I take this inequality here and I multiply it by positive 2. And so what I'm hoping is, no matter what manipulation I do, the sign will always be facing this direction. It'll be always facing left, because as long as I can predict which way the sign will be facing, then I can always multiply or divide by any variable, as long as I know it's not equal to 0. So if I multiply each of these guys by 2, I get 16 and 8. And good news, 16 is still greater than 8. If I divide each side by 2, I get 4 and 2. And 4 is greater than 2. So this looks good so far. It looks like I can multiply or divide by anything as long as it's not 0. What about, though, if I multiply negative 2? Then I get negative 16 here, negative 8 here, and negative 8 is, in fact, greater than negative 16. And if I divide by negative 2, I would get negative 4 here, and negative 2 here, and negative 2 is greater than negative 4. So when I am multiplying or dividing by a number that is less than 0, it flips the direction of my inequality sign. And in fact, that is the only thing that you need to take into account. The only thing new you need to take into account when dealing with inequalities instead of equations. And so there's two things you need to know when you are multiplying or dividing by a variable with an inequality. You need to know it's not equal to 0, and you need to know its sign. If it's greater than 0, the inequality retains, the inequality sign retains its direction. If your variable is less than 0, then it flips direction. So if I were to say, if I was just given this, 5xy is greater than 5xz, and they tell me x is not equal to 0, we cannot divide each side by x because they don't tell you its sign. So you would not know which way to flip your inequality sign. Or I should say, you wouldn't know if you need to flip your inequality sign. But if they tell you x is not equal to 0, and x is, in fact, they tell you x is less than 0, now you can divide each side by x because you know what to do with your inequality sign. You need to flip it. Likewise, if they told you x is greater than 0, you would know you do not need to flip your inequality sign. So if they tell you x is less than 0, you can divide by it. So we can still divide by 5 because 5 is positive. Sign retains its direction. Now if we divide each side by x, because we know its sign, x is less than 0, we know we need to flip our inequality sign. And this is in fact telling us z must be greater than y if x is less than 0. For equations, don't care about sign. We just need to, we only care about knowing that our variable is not equal to 0. With inequalities, though, we need to know the sign when multiplying or dividing. By a variable or by a number. Well, that's it. So for equation, when you are doing manipulations, there's only one thing you need to take into account, and that is that you cannot divide by 0. With inequalities, there's really only two things you need to take into account. You cannot divide by 0, and you need to know the sign when you are multiplying or dividing by a variable. So that is the only thing that is different. Everything else you should already know from having worked with equations. So now let's take a look at some inequality problems where we have to use these principles.